So here we have another graphing question, and if you read this text here at the beginning, up here, it says in the complex plane, the horizontal axis is called the real axis. That's this guy right here, and the vertical axis is called the imaginary axis. Right there, this has to do with graphing complex numbers, numbers that have a real part and an imaginary part. And the complex number a plus bi, okay, I'm going to circle that right here, a plus bi, is graphed in the complex plane comparable to the point A comma B. So in other words, if you have a number, let's say we have a number, a complex number, 3 plus 4i, the way that would graph in the complex plane is you go over to the point x equals 3, which is right here, and the point y equals 4. Remember, y is representing the imaginary axis, and that's your point right there. So that dot that I just made is the point 3 plus 4i when graphed on this plane, or in other words, 3 comma 4. So that's what we're talking about. Now, if you keep on reading, it will tell you that the modulus of the complex number is given by this right here, a squared plus b squared, and then you take the square root of it. And it wants to know which of the complex numbers that you see in this graph, z1, 2, 3, 4, 5, see all these little blue dots here, which one of those has the smallest modulus? So in other words, which one has the smallest value of the square root of a squared plus b squared? So to explain this one, I want to dig into what that a squared plus b squared thing is a little more. Those of you who are familiar with trigonometry should understand this. And I'm going to pick, here, let's pick this point right here. I'm going to blow this up a little bit. So if you remember, this is a comma b right there, okay, the xy coordinates. So this line that I just drew here is the x distance, that's a, and this line right here, this vertical distance to that dot, is b. So remember what my equation is for the modulus. It's the square root of a squared plus b squared. So let's talk about what a squared plus b squared is. Do you remember Pythagorean's theorem? That tells you the formula for finding the hypotenuse of a triangle. And this length of the hypotenuse is the square root of a squared plus b squared. So if you think about what the modulus represents, what we're talking about is the distance from the center of this graph to the location of the blue dot. And now look at what this question is asking for. It's saying, which of these dots has the smallest modulus? The smallest modulus, in other words, the smallest distance from the center. Well, you can see Z5 has the largest distance. This thing is very, very far away from the middle. And the one I actually picked here, Z1, that's the one that's closest to the middle. So when you're closest to the middle of the graph, you have the smallest modulus. And that would be our answer, this Z1 right here. Okay. In the end, this wasn't really about imaginary numbers and real numbers and how you plot them on a complex plane. It was about recognizing the relationship between an equation, this equation right here, this a squared plus b squared square root, recognizing the relationship between that equation and a picture. It's a distance equation for the hypotenuse of a triangle.